Let's start talking about confidence interval. For what? We have for mean, and we have it for variance or standard deviation, because we know, and when I talk about confidence interval for mean, I mean the mean of the population. And when I'm talking confidence interval for variance, I'm talking about the variance of the population. Okay? And then I end up with proportion. Okay? This proportion of the event in the population, I call it P. And it is fraction less than 1, of course, right? Okay. And we remember, when we go for the confidence interval for the mean, we have two options. If we are given the variance or the standard deviation for the mean, for the population, or the sample size bigger than 30, we will go for Z. Okay. But if we go and we don't know the variance of the population, okay, and the sample size less than 30, we choose the T table in the formula. We are going to find the confidence interval. Okay. Now, here, the confidence interval in this case was what? Yes, mu bigger than what? Yes, the sample mean minus the t-score for alpha over 2 times sigma over root square n. Okay. Okay. And between, yes, x bar, the other side, you just change this one into plus, right? So it will be x bar plus z 1 minus alpha over 2 sigma over root square n. If n greater than 30, you just replace sigma by s. What is the difference? This is the variance of the population. S is the variance, is the standard deviation of the sample. So you go to this one and you replace sigma by s. Finished? Finished. This is when sigma known or n greater than 30. We go for t. I'm not going to write it again. You just replace z by t and sigma by s. So you need to have the standard deviation of the sample, okay? And you need to have the mean of the sample when you are going to find the confidence interval for the mean, using t or using z, right? When you go for the variance, you go for the chi-square, because one sample, all of this one, you have only one sample, right? Yes, you have one sample. You have to get a sample, one sample with size n, with size n. Okay. For the variance, you go for the chi-square, using chi-square, and your variance, which is sigma square, will be greater than what? The left chi-square alpha over 2, and yes, n minus 1, as far as I remember, over s square. And in the other side, you have chi-square 1 minus alpha over 2. And remember, the chi-square has degree of freedom. So you have to remember, nt, you need the degree of freedom. And in chi-square, don't forget the degree of freedom. The degree of freedom is the sample size minus 1. The degree of freedom here also is the sample size minus 1. In Z, no need for the degree of freedom because the table of Z doesn't have degree of freedom. Okay, n minus 1 over s squared. So be ready when you find the confidence interval for the mean. You need to find the mean of the sample, and no need for the standard deviation if you have it for the population, and you need to have the standard deviation of the sample when you don't have the standard deviation for the population, and the one condition when you have the sample size greater than 30, right? If n is less than 30 and sigma is unknown, you replace z by t and sigma by s in this formula. This is the confidence interval. For the chi-square, or for the variance, we use the chi-square for one sample to compare variance. And we have this confidence interval from this one. Today, we are going to go for the proportion of any choice in the population, okay, P. And we know the proportion of any event is the number of events in my sample over the sample size. So it gives me the proportion. What we are going to use for the proportion, we are going to go for Z, T, or chi-square. Proportion is related to the mean. The proportion is related to the mean when you have qualitative data. Okay. So this proportion, in this proportion, you are going to use Z score. Do you think the formula will be the same as this one? Yes, it will be. So for the proportion, I remember when I have a proportion, I remember the binomial distribution. You use it, for example, if you have a coin and you have a head and tail, if you toss it once, you will have the probability of head is equal to the probability of tail equal to, you have 50-50, so the probability will be 0.5. Okay? The probability of having head, if you toss it once, you will have it as 1 over 2, which is 0.5. But what about if I toss it 10 times or 100 times? Do you think you will have 50-50? Of course not. So if you toss it 10 times, the probability of having head will be exactly the probability of having head, I call it P, and I toss it 10 times, so it will be n times the probability of the event if I toss it once. So yeah, NP. This NP, or the probability of having head, when I toss it n times, okay, n times, it will be the mean. This is, I call it the mean. Okay, once you have the mean, you can talk about the variance. Okay, so what is the variance? So the variance will be what? Yes, it will be NP times Q. Okay, so this is the mean, this is the variance. What about the standard deviation? I know the standard deviation is the root square of the variance. So the standard deviation will be the root square of NPQ. So sigma will be NPQ, right? So in the proportion, I'm going to go for this one, and I replace sigma by root square NPQ and replace x bar by NB. That's it. Okay. This is the link between the proportion and the mean. And the confidence interval will be, instead of the mean, I will have the proportion plus or minus z score. If you are in the left, it will be z alpha over 2. If you are in the right, it will be z1 minus alpha over 2. It doesn't matter because z is symmetric. Once you have one, you change the sign, you will have the other one. Also, t is the same. So this is exactly the same as this one. I replace x bar by the proportion. I replace sigma by the root square NPQ. Root square NPQ over the root square n. So I will have under the root square NPQ over n. Okay. So when I replace x bar by NP and replacing sigma by root square NPQ, I will have this formula, right? So this is the formula of the confidence interval. Okay. This part is called the standard error. This part, we call it the standard error. Even here, we call this part the standard error, right? Okay. Now you have to know the notation. P is the proportion for the population or population proportion. B hat, you can read it as a sample proportion. So as x bar and mu, x bar is the sample mean, mu is a mean of the population. You have to distinguish between the proportion in the population, which is B, and B hat is the proportion in the population, in the sample, sorry. And P is the population proportion. How I can find the proportion in the sample? You count how many times you are choosing, as I asked you for your, if you would like to specialize in pediatric or dentist surgery or something. So I can use this data to have the proportion in the sample for one of these choice. Okay. No need for Q hat because Q hat is 1 minus P. If you are looking for probability of something, the opposite of this event will be Q, and Q will be, and the total of the probability is 1, so Q hat will be 1 minus P. Okay. And this is the formula for the confidence interval for the proportion of the population in the middle. And this is a proportion in the sample. And we know how to use Z table to find Z alpha over 2. And it must be in the Z negative Z table. But if I don't have negative Z table, I can use the positive Z table and I change the sign of the value of Z. P hat is the sample proportion. Q, it is better to replace it by 1 minus P hat. Okay. How to find the sample size if you have qualitative data, like a choice or something like this, from this formula? As we have done last time, okay, I multiply P by this value and I get N in one side. So the sample size, if you have proportion, okay, of the sample and Q hat is 1 minus P hat, Z alpha over 2 over the error, the allowed error you would like to have, right? Square. So this is the formula for the sample size for when you know the proportion and you have qualitative data. Okay. Let's go for this. You can apply this one instead of the rugby game. You can apply it for this choice. Okay. So you know this data, but the problem is what? He's looking for what? Yes, for probability of having something specific, right? Who is going to win the World Cup in 2003 up to this data? Okay, Australia win 116 times, England won 13 times, etc. Right? If you ask some people, right, who is going to win 116 of your 480 samples, saying Australia, and 13 from your 480 person you ask it, having 13 for England, 25 of the 480, they said France will be win, and etc. And the question is, up to this data, can you find the confidence interval for undecided? If I'm not talking about the sample now, I'm looking for the proportion in the whole population, but I cannot ask the whole population. Like here, I asked my student in applied biostatistics, when you graduated, which major you would like to have extra study. But this sample will give me indication for the proportion from each choice in the whole population in the College of Dentistry, right? This is the point of the choice. I know I have to know the confidence interval before I start finding the interval confidence for proportion or for the mean or for the variance. Opposite to confidence interval, you have something called level of significance, which I call it alpha. If I have the confidence interval 90%, it means the level of significance alpha will be 100 minus 900% minus 90%. Okay, so sometimes you are not giving alpha, which is the level of significance, you are giving the confidence interval. Fine. Without giving you this one, you cannot manage any formula here. Sorry. So you have alpha here, you have alpha here, you have alpha here. So you have alpha everywhere here, right? Okay. So I have to know the level of significance, or if I know the confidence interval, I have 100% minus this percent, the confidence interval, I will get the level of significance alpha. So he's asking for the proportion not decided. Okay, like what here? Like one of your classmates say it's up to the market, so he didn't decide it yet. Okay, so can I apply the same into this one? If I would like to know what is the proportion in our population in College of Dents, which is my population, up to the sample I am asking them, right? Okay. So you should have the proportion for the event you would like to get the confidence interval for. Okay. He's asking for not decided. So how many one not decided? 65 out of 400%, 480. So this is a proportion of the sample. I'm looking for, yes, alpha. I am giving the confidence 90%. So alpha will be 10%, right? Alpha will be 10%. So I'm looking for Z alpha over 2. How I can use Z table? I'll go for Google and looking for Z table. Okay. If you go for Z table, this is the negative one. If I go for alpha over 2, I'm given alpha 10%. Alpha over 2 is 5%. So this is the 5% I'm given, right? So I'll go for Z 5%. Do you see the 5% here? So this is the one you are looking for, right? I don't like to use the negative. I can use a positive. So this is the easy one, the positive. So I'm looking for, yes, 1 minus alpha over 2. 1 minus 10% over 2, it will be 0.95. Do you see 0.95? I don't see 0.95, but I'm seeing 0.9495 and 0.9505. So I'll catch the main value of Z, which is 1.6, and I'm looking for this one under which decimal place. It is under 0.04 plus 0.05 over 2 and add it to 1.6. So my Z will be 1.645. Now I have the proportion of the sample. I get the Z of alpha over 2, or this is the Z alpha 1 minus alpha over 2, because I got it from the Z positive, right? The confidence interval, this is the formula, P for the sample, here it is, plus or minus Z of alpha over 2, right? 1 minus alpha over 2, 1.645, root square of P times Q. P is 65 over 480. Q is 1 minus P. So 1 minus P will be 415 over 48 over N. N is the sample size, which is 480. This is the confidence interval for the proportion. Okay. So the proportion of undecided will lie between 11% and 16.1%, right? Okay. Up to 90% confident from this result, right? Okay. If I got the decimal for this fraction by the calculator, I will have it as 0.13, so 13.5 something. Yes, so this one lying between this one, which is fair enough. So the confidence interval depends on what? Depends on your sample, right? And of course, depends on the confidence interval. Okay. Now, this is a question. To answer me, one of them, what you are going to do, I have to decide it. I am going to do what? I'm going to do confidence interval for mean or for proportion or for variance, right? But now I know I have a question for the proportion, but I have to read the question. Okay. Once I see proportion, so I know I go for the confidence interval for the population proportion. What I need in the formula, I need the sample size. Where is the sample size? Yeah, for section A, he gave it to me 60. What is the proportion of the sample? is 0.54. What is the confidence interval? It is 99%. Okay, so let's do it, please. First of all, I have to write the formula, the confidence interval for population proportion is what? B bigger than or B hat minus Z alpha over 2. And here you have root square of BQ over N. Is it correct? Yes. BQ over N. Okay. So what I need the sample size, N, and the confidence interval or the level of significance. Alpha. Okay. What else I need in the formula? Yes, I have to know the sample proportion which I call it B hat. Okay. And once I have B hat, I can have Q hat, which is 1 minus B hat. This is all what you need. And of course, once you have this one up to this value, you will get Z of alpha over 2, or I prefer 1 minus alpha over 2 to use the Z positive, right? Let's go for our question. This question had 3 parts. I will solve the first part. So what do you have? What is N? The sample size is 60, right? The confidence interval is given to you 99%. So alpha will equal to what, guys? If the confidence interval is 99%, alpha will equal to what?
0.1.
Yes, 1%. Yes, thank you. 0.1, yes, right. Which is 0.01. Thank you so much. P hat, the proportion of the sample is given to you 0.54. What about Q? Q is 1 minus 0.54, which will be 0.46. This is Q hat. This is P hat. Okay. Now, We are going to go for Z. So I'm looking for Z 1 minus alpha over 2 is 0.01 over 2. So I'm looking for Z of what? 1 minus 0.01 is over 2 is 0.05. I'm correct? Yes. So this will be Z for 0.995. Is it okay? Guys, can we get this one from the Z? Let's go for the Z table and looking for 0.995. What is 0.995? I have 0.9904 and I have 0.9906. I'm looking for 0.995. Can you see it? No. Very close to this one. Which one? Yes. Can you see this one? I will catch it by the snipping. Can you catch this one? 0. Oh, good. I'm looking for 0.995. I don't have 0.995, but I have a very close one. Okay. The main value for Z, this is the Z, right? This is the Z. Okay. It's 2.5. So what is the second decimal place? I have this is 0.0, 0.01, 0.02, 0.03, 0.04, 0.05, 6, 0.07, and 0.08. So in between this one, so what I'm going to say, I'm adding to 2.5 this two decimal place. Here you will find 0.08. Sorry, I'm not good. Okay, and here you have 0.09. I'll choose this one or that one. No, you take the average of this one and that one, right? So I have 2.5. Yes. 2.5. This is the main Z plus 0.08 plus 0.09 over 2. So what I have for Z? It will be 2.585, right? So this is the Z. Now I have everything.
Doctor, I have a...
Sorry?
I have a question.
Yeah, go ahead.
Doctor, where did you get 0.005 from?
From the table of, this is the Z. Yes, from the beginning here.
Yeah.
You are looking for
minus 0.00.
Yeah. As you know, you have here Z for alpha over 2, right? And in the other side here, you have Z of 1 minus alpha over 2. Catch it? So this is in the negative Z. This will be in the positive Z, right? If you don't have a Z table for negative, you go for the positive Z table to have Z alpha over 2, right? Because Z is a symmetric shape. Okay, so the same value for Z, but different sign. Okay, so instead of going for Z alpha over 2, I will go for Z 1 minus alpha over 2, right? 1 minus alpha over 2, okay, take your time. So 1 alpha over 2 is 0.995. When I go for the table, once you have the probability more than half, you are in the right side or the Z positive, right? This is why I would like to have 1 minus alpha over 2 to go for Z positive. I'm looking for 0.995 in the table here. I didn't find 0.995. So what is the closest one to 0.995? It is 0.9951, but this is bigger, and I have one less, 0.9949. The main point to have the value of Z is 2.5. And now to decide it, you are going to go for this decimal places or decimal place. This is in the decimal places of 0.08. This is in the decimal place 0.009. This is why I have to add them together and divide it by 2. I end up with Z equal to 1, 2.58. Now I have the confidence interval and I'm going to substitute. What is P hat? P hat is 0.54. What is Z alpha over 2? It is 2.85. Okay, root square of what is P? 0.54. What is Q? Is 0.46. What is N? Is 60. All of this one under the root square. Can you catch me this number? 0.454 minus 2.85 times this one. Okay. Okay, I will delete this one. So what is the P hat? 0.54 minus Z alpha over 2 is 2.85. Okay, times root square of B is 0.54 times Q, or 1 minus B. I would like to write it 1 minus B, 1 minus 0.54 over N 60. Right? In the other side, the proportion of the population will be less than the same value, but instead of minus, I make it plus, right? Can you give me the final result for this one? Guys?
Doctor, I got it at 0.366. 0.3668.
Thank you. And the right hand side?
Zero 0.7233.
Thank you. 0.7.
0.7233.
Thank you. How I can read this value, right?
Doctor, I have another question, please.
Go ahead.
Doctor, you substituted the Z value with 2.85, but
Yeah.
didn't we find it as 2.585?
2.8. Ah, sorry.
Yeah,
This is my mistake. Sorry. Thank you so much. Thank you. Sorry. Instead of writing 2.58, I write it 2.85. Thank you. I'm so sorry about that. Okay. 2.55, right? 2.58, sorry.
Yeah, 2.585, because we found the...
Yeah, I wrote it in the opposite side. I write 85 and instead 58. So the value will be different, right?
Yeah, exactly. But doctor, isn't it supposed to be 3 decimal places? Because we found the average of 2.85 plus 2.59, which
Yeah.
came out as 2.585.
85? Okay.
585.
Yeah, yeah, yeah. If you would like to be more accurate, yes. 0.54 plus 2.585. Thank you so much. Yes, you are right. So what is the proportion of the population be? It will be lies between what and what? It will be close to 0.3 something. Okay.
Doctor, for the right, 0.373.
373.
Mm-hmm.
And the other side?
Will be 0.706.
Thank you so much. So I have to apply this one up to my question, right? So the proportion of the population or the probability of success P will be between what? 37.3%, right? And 70.6%. This is how to read this one. So the proportion of the population for the same event, I choose the sample to get this information. It will be between 37.3 and 70.6. So now you can do B, okay, and C, okay, and you can catch. This is a confidence interval for the proportion, but I have to read the question. Okay, but what about this question? Find the 99% confidence interval for the mean. So I have to remember, I go for the mean confidence interval of the mean, and I have to decide that I'm going to choose T or Z. So I'll go back to my question and I'm asking you, are you going to use here Z or T? I'm looking for the standard deviation and the sample mean. Do you have the standard deviation over here? Yes. A medicine manufacturers pots to a set length with a variance of 6.25 millimeter. A random sample of size 20. So the variance of the population are given. The sample size is 20, right? So I'll go for Z. It is given for you the 99% confidence. So the level of significance alpha will be 100% minus 99%. So alpha will be 0.01. So I go for the formula of Z. Okay. And I'm going to know N is given. Okay. N is 20. Sigma is given to you in the question. Sorry. 6.25. Right? and alpha will equal to 0.01. Everything is okay. Once I know alpha, I'll get z of 1 minus alpha over 2, substitute in the confidence interval of the mean. After I decided I have sigma, so I go for z and go for this function. That's all. Okay. What about the next question? Are you given here the variance, or what's the question? What is the 95% confidence interval for the acceleration time? Okay, so I don't know if this is a mean or the variance or something. Can you decide it, this one? Okay, what about 6? Confidence interval for the average. So the average is the same as the mean. Catch my point? Okay, so I'll go for the confidence interval for the mean. I'm going to use Z or T. Hello? You get a randomly sampled.
Doctor, the variance is given. So
It's given for the sample or for the population?
For the sample.
Aha, this is a trick in this question, right?
Yeah.
Catch it? So remember, yes, the given is not sigma. The given is what? Is S. Okay? So you have to be very careful when you are reading the question in statistics. He said the random sample with size with the mean 50 and variance 400. So this is for what? For the sample, not for the population. Catch it? The other two questions. Yes, you are given with a standard deviation. Yeah, here's the standard deviation.
Use which one?
Sorry?
We use which one for number 6?
I'm saying this is the standard deviation for the mean. And n, you have the sample size here. $15 credit cards, huh? You have a 15, right? So n is 15, n less than 30, right? And what is given? The confidence interval average amount for these cars. You have the variance 400 and you have the mean 50. This is for what? This sample mean sample variance or the population variance, the 400. Up to the answer, you will choose Z or T. Can you answer me, please? The variance 400 is for the sample or for the population?
No, it's for the sample itself.
Sample. Okay. Yes, for the
Yes,
sample, so you have to go for the formula using the sample, not the sigma, right? Okay. Okay. That's all. Very easy, very simple when you practice. Okay. I collect this question for the confidence interval for the mean using Z or T, for the variance using chi-square, for the proportion using Z, and I will leave you to answer 1 or 2 questions, okay? And we'll decide what is a mistake, what is a problem, what you are going to face using the table or using the calculator, okay?